Hello and welcome back to the Redstone Tutorial Map. I'm going very slowly in this map, so it probably takes me about 30 episodes, I would guess, to actually get through it. But that's fine. I like that anyway. I do go through things very slowly. I believe we start on the right hand side, I'm not sure. Repeaters, yeah, it looks like that's the case. I actually don't mind starting on the right hand side, it makes a difference. From always starting on the left hand side and going right. So, repeaters. Some reason there's a bookshelf. Yeah, obviously I've been using this stuff already, but it doesn't really matter. Yeah. And I've been a little bit affected by the fact that I just did something in Britannia where I used droppers. But seeing that as a mechanism just like a piston is not necessarily a bad thing. And probably I should start thinking about all of the different things. I mean, not note blocks, but maybe. I mean, I don't know. Because I would imagine note blocks are the ones that I'll be least interested in. No, it's not particularly interesting. Okay. So yeah. So obviously you can do it, and unfortunately there's no way to put one here, as I've learnt many times before. And they refresh the signal, they will return it to a state of 15. So yeah, so we go 15, 14, 13, 12, 11, 6, 1. It will take in the signal of 1. It won't be at 0 here, it will be at 1. And then it will go to 15. 15, 14, 13, 12, 11, 6, 1. And that's the thing, it's always important to sort of see that it's to do with if you take it as a prefix or a suffix in a sense. So you could say this block yeah, I mean it's almost like at this block we're going to take the signal. So I mean it's probably a suffix, isn't it, in a sense. We're going to take the signal of 1 and then we're going to do the action. But with a repeater you can say we're going to take the signal of 1 and then we're going to do the action. And because the action is updated to up to 15, it's then going to just output the 15. So yeah, it's not going to just say, you see, whereas something else it would just say, yeah, I mean something else would probably just say, yo, it's just going to be 0 after that anyway. But see, probably the default state would be after that action of taking the input as 1, make it 0 for the, you know. But obviously that it's not going to trigger. So yeah, okay. What else we got then? Repeaters can be locked in specific states by powering their sides with either a repeater or a comparator. So do I have them both here? Comparator, yeah, I do. I don't think I've even looked at comparators though. Yeah, you see, I never learnt this at all. And honestly, comparators are the one thing I've never learnt at all either, which is a bit unfortunate. Because I've been playing Minecraft for a very long time. That I never. By that time, I was just into the mods, and I just didn't bother even thinking about comparators and stuff. Repeaters can be locked to specific states by powering their sides with either a repeater or comparator. Alright, so basically, by powering their sides, so basically this edge here, this edge here, so two of the 4 rather, 6 even. That'd be funny if a repeater was actually 3-dimensional. That would probably cause more problems. So, and especially in I remember when Forge Multipart came out and you started having the torches in the same block space. That was interesting. I don't know if that even they still do it like that. I mean, I could obviously play a version where it isn't like that. That was quite the thing, though. It seemed quite a big deal, though. But anyway, the point is, two of the 4 sides Yeah, so basically you can see that the non-IO sides, I guess, are the ones which can be affected. This is the only thing that actually affects the repeater from the side when you think about it. If you do anything else to the repeater from the side, nothing will happen. Yeah. So yeah, so you can lock it like that. Or you can do the, so yeah, there's basically, so I guess there's four different. If we took these two as a combo, we could say when the repeater is active, when the repeater is inactive, when the repeater is, so say this is a 0, so this is an A and this is B, yeah. So A is 0 here, and B is 0, and then we'd look at the, and then we take this, say this is X. So when X is 0, A and B are 0. Output is 0. So when, and then we could say when X is 1. Yeah, well, I suppose you can't really do it like that. I don't know. I'm thinking obviously about what happens with the. Because you see, when X is, you see, that's the thing. But this becomes a dependent. This state becomes a dependent variable of this, which is the independent variable, I guess. I don't know. I'm probably thinking too maths-wise. That's the thing. I would be careful not to think too maths-wise about everything because I know it's not really maths. But I often think more maths-wise about things than not. But yeah, 0, 0, 1. Yeah, I mean the interesting thing about the locking mechanism, right, is that then this actually becomes an independent variable. Yeah. Yeah, well, it's independent with respect to X, isn't it? A is independent with respect to X. But you could say, if, for instance, if this was a different state, if this was like a, you know, like a state, you know, this was like, there was like two states, and that was state 1. This is state 2. That state is dependent on this, I guess. So there's different ways to look at it. All of them, I think, are kind of correct. And you probably need to sort of concatenate them in some way to work out how to do all the stuffs. So there we go. I'm not really sure what else I can think about here. This may have been the one that I got really fucking confused on. Okay, this is the thing which I really want to get like super bad. Because this is like the most important thing. This is how you actually do everything, and from what I can understand, really. Falling edge and rising edge trigger. So you're looking at the state change from 0 to 1, and I can't remember if 0 to 1 is rise. 0 to 1 it sounds like rising. 1 to 0 sounds like falling, but probably wrong. I mean, I've got a 50% chance of being right, so it's better than 0, and it's better than 49.9 as well. So. Yeah, I keep forgetting that they call Redstone. I keep thinking this is not what RS means. That means resettable. So delay applies on both rising and falling edges. If delay is greater than pulse, then the pulse will take the delay's length. So that makes... Okay, how does that... I don't... Okay, one thing I know is that they're obviously set up to, from the right. So the... I don't know. For some reason I want to use the term TTL, time to live, because I just heard it in networking. Or what other terms I've heard in networking? Hops. Okay, so say this takes X hops, this takes X plus 1 hops, X plus 2, X plus 3, X plus 4, right? That's a good way to look at it. At least I know that I can know the sort of the ordering in a set of the numbers, right? So yeah, so this is at 1 tick, isn't it? So how long does this take? Well, that's a good question. Yeah, I think the general feeling is that when you turn this lever on, it takes Yeah. I need to watch it. Maybe I should watch this video at like 0. I could actually use YouTube to watch it super slow, just to check that that is actually turning on like immediately and not like waiting like a tenth of a second to turn on. I think you can actually do. I think I remember doing this and I did it so fast I ended up fucking it up. Yeah, you see that middle one? That's an interesting thing. But anyway, so this is 0.1 seconds. Yeah, here we are. There's something on here. 2 ticks delay torch diode. So when we have this set up here, that's actually taking 2 ticks, and I assume that means 2 redstone ticks. Because obviously I know a game tick is 0.05 seconds. And that's why when you have a 1 tick pulse, I believe that actually refers to 0.05 seconds. So 2 ticks delay torch diode. Yes, so we just say there's x plus 0.1, x plus 0.2, x plus 0.3. So say like that. Probably a better way to look at it. So what I think this is, I think that's exactly what it's saying here. It's saying, look, there's no... Do these two come at the same time? You would think if this is 2 ticks, and this is this whole machine is 2 ticks delay. Those two should be exactly the same. Let me just check if that is the case. Yeah, I think the very right one is first. These two come at the same time, and then the other two are slower, right? Yeah, the other two are slower and also different, I think. Yeah, that's the way it works. So these two are exactly the same. So essentially, if you want a device to output... Yeah, I think that's really what it's saying. So what's this? Let me just read this again. If delay is greater than pulse, then the pulse will take the delay's length. Interesting. Okay, so... Huh. I think I kind of understand it. Yeah, I think I do kind of understand it. I think what it's trying to say here is that basically what yeah. So for instance, this is 3. Yeah, you see this doesn't really, and this will be at a 4. I'm not sure the fact that I could... Yeah, I think the interesting with this thing is that... I mean, it's interesting that it does that. Basically, obviously what's going on is that I'm clicking it with it in less than 0.2 seconds. So my pulse is 0.1. Yeah, the pulse would be, say my pulse is 0.15 or something. The delay is greater, then it will take the delay's length. Huh. So why is this stuck in there then? But it's not here. So there's obviously something different going on with this. This I think is probably, if I look at what's coming up next, imperatives as well. This is where I'm starting to struggle a bit with this, because I don't really understand why this has happened. So why would it happen? So that's the thing. I know it happens like that. Why does this happen though? That's such a weird thing. I know it happens, and the obvious reason is the pulse length is less. So it does that. So what it's saying is this piston needs a pulse of at least 0.2 seconds, I guess. It's actually quite hard to get it. Yeah, you can get it though, but it's not. It's obviously about between less than 0.2 seconds. Let me just. Here's the funny thing. At no point. Oh, actually. Oh yeah, it does always get stuck like that. So maybe I'm not seeing anything. It seems to... What? It's funny. If the delay is greater than the pulse, then the pulse will take the delay's length. Yeah, but it will. I don't. It's a bit confusing now because I think probably it would have to. It seems like it. Then the pulse will take the delay. So what is the delay? The delay is basically. Yeah, certainly the redstone torches are some kind of repeater block, right? Like you can see it just even from this thing, right? Is that yeah? I mean, you could see the delay there. It was quite a long time. So it's basically like a repeater, this thing, but like an inverted repeater, and with different placing ability. But it does extra stuff. I mean, I think really what I'm thinking about is the both rising and falling edges. Delay is greater than pulse, then the pulse will take the delay's length. I think really the only way to really look at how this might work is to do another sort of... Oh, there's actually some more stuff over there. Oh well, we won't look at that yet. Yeah, what we'd need to do... Yeah, I just do wonder about this. So what? I mean, if you have loads of repeaters... The thing is, if I have loads of repeaters, I know what's going to happen. I don't want to have any repeaters because I don't want that to happen. Yeah, we'll use... It's obvious. The thing is though, it's obvious what happens with repeaters. You just, even if you flick it for a second, the signal will just take... Yeah. I guess really it's not really saying anything that complicated. It's just it's just, I'm not... You see, it's easy to visualize, right? This, right? It's easy to say... Well, it's not really. So yeah, let's put this swim in it. So this delay is 0.4, 0.8, 1.2, 1.6 seconds. Is that 1.6 seconds? I guess I really don't understand this now I think about it. Let me make it even bigger, just so I can really understand it. So if delay is greater than the pulse, so I'm going to pulse it for 1 second now, right? You see, to me that seemed like the pulse was exactly the same length as as the the. It seems like the output, what this got was the same length. If delay is greater than the pulse, then the pulse will take the delay's length. And this is somehow dividing it by half because of this. I'm not sure. Yeah. I will have to look at this more topic. I think. Yeah. I guess I'll move on to comparators. I'm not sure exactly what else I can really say about that. Oh yeah, I missed this bit. The repeaters are diodes. Is that a spelling mistake or is that actually what they're called? I assume it means diodes. They only accept inputs from the back and send signals to the front. Yeah. Okay. Let's see what else we've got here. Repeaters refresh the signal for another 15 blocks here. And it can be locked. There may also be a definition of diode I'm not really aware of. We'll see then. Comparators, yeah. They're also diodes. Yeah. Alright, I think I'll just do this one in the next episode. I need to look at, I'm probably, honestly, like similar to what I did at the beginning of episode 3, I'm going to probably want to go back to this, take a look at the rising and falling edge thing a little bit more closely. So I will do that in the next episode. Thanks for watching.